Hi there, and welcome to the Air Equipment LLC YouTube channel. This is our fifth and final segment of our discussion of life safety dampers. And we're going to talk now about some accessories and options that are part of the life safety damper product offering. Quite often in a building, there's not the simple duct penetration from one side to the other, and it's easy to install a standard fire damper with the mounting angles. Once in a while, we'll have ductwork will terminate at the wall with a return grill, and so you can't have a sleeve protruding through both sides of the wall. And in that case, you would use a special front access or grill access damper, as shown here. These dampers terminate right at the plane of a wall, and the grill covers it up, and you can take the grill off to access the actuator motor or to service the damper. Once in a while, the penetration of the ductwork through the floor or wall is simply not big enough to have a damper fit inside there. So what's used then is an out-of-wall damper. This is a special damper where the damper sleeve is coated with refractory fiber, and this maintains the integrity of the damper. And as you can see in this illustration, both on the left side, the damper is mounted in a floor, but the damper itself is actually below the floor. And on the right side, the damper is mounted in a wall, but the damper itself is not in the plane of the wall, it's on the left side of it. But that refractory fiber material maintains the integrity. When the damper blades close, it's secure enough so that the partition itself now has its rating, whether it's 2-hour fire rating or whatever. But a special out-of-wall damper can be used in these very tight situations. In a modern building, the building management system likes to be wired into all the different components of the HVAC systems, bring it back to the central computer. And so with our life safety dampers, quite often we need indicator switches to tell us what the damper is doing. And this slide right here shows some of the different options that are available that give us a signal of what the blade position is, instead of having to inspect every damper, because of course some of them are mounted so deep into the structure of the building it's very hard to get to. When we have these blade position indicator switches that are wired back to the central computer, we can not only know for sure what the blades are doing, if they're in the open or closed position, but also cycle test them remotely, as should be done quite often, to make sure the damper will operate. The dampers actuate using fusible links. Sometimes that's just simply a couple of pieces of metal soldered together, and when it heats up, that solder melts and the two sections pull apart, which allows the curtain blade of the damper to close. With a combination fire smoke damper that's motor driven, there is no fusible link that melts. There is instead what's called an electronic fuse link, the EFL, and that's a little heat sensor. And when the temperature of that sensor goes up to the 165 or 212 degree limit, it will actually signal and shut off the power flow to the actuator, which allows the spring return to close the blades. There are a number of different sizes and shapes of these various items, depending upon what's needed for the particular application and the type of damper. Inspecting, testing, and maintaining dampers is really crucial. After all, these are life safety products. These are designed to help save lives in the event of a fire. The problem is, dampers are installed way up and out of the way, out of sight, out of mind, and unfortunately, they're not tested nearly as often as they ought to be. We can see here some of these photographs. On the left-hand side, there's a test switch where this is a motor-driven damper. You press the switch, it cuts the power, and then you see whether or not the blades close properly. On the right side of this slide is a typical curtain-type damper, and the mechanic at the facility is removing the fusible link and allowing the damper blades to close all the way, and then of course putting the blades back up in position and reapplying the link. Here are a couple of photographs from actual job sites showing older dampers that have not been maintained, have not been tested. And the photograph on the left, the fusible link is gone. This damper should be closed. However, it's so dirty and gunked up that it's it's stuck. It's stuck in the open position. And if there ever was a fire here, those blades would not close and flame would be allowed to pass from one side of the rated wall to the other, which is completely in violation of what we're trying to do with these life safety dampers. The photograph on the right, you may not be able to see it clearly, but there are screws that have been put in the track of the damper frame, which is where the blades are supposed to travel. So if there ever was a fire and this damper wanted to close, it would get hung up on those screws and not be able to close and do its job. And I've been told, it may be kind of an apocryphal story, but out in the field of building maintenance, it's said that the most common replacement fusible link is not an actual link because the maintenance guy can't find one in his supply drawer. What it is a sawed-off broom handle that if the link breaks, what they'll do is measure how high the damper is, saw off a piece of broom handle, shove it up on the side of the damper to get those blades up out of the way so air can flow through the duct, and then the maintenance guy makes a mental note to go and get some replacement links, which he promptly forgets to do. And so you have a hunk of wood or sometimes metal holding that damper up in place. But if there ever is a fire, it's not going to close. It's not going to do its job. Life safety dampers ought to be tested and inspected on a regular basis. There are a lot of guidelines. NFP 80 talks about it, testing the damper 1 year after installation, and then it should be tested every 4 years after that. There's various other codes and recommendations for testing at different intervals, but the problem is that it's not really enforced and very few people do it faithfully on a regular basis. And so quite often a damper will go 2, 4, 8, 10, 15 years without anyone ever looking at it. And then if it ever needs to actually work in the event of a fire, there's just all bets are off on whether it will work. Way back in 1980, there was a horrendous fire at the MGM Grand Hotel in Las Vegas. And unfortunately, 85 people died and over 700 were injured. The fire broke out early in the morning on the casino level of the building, and most of the deaths were due to smoke inhalation. And a lot of the smoke went up elevator shafts and stairwells, and it was just everything that could go wrong did go wrong. There were some fire dampers in the building that they found out later on that the blades had been screwed into the open position and could not close, and some of them, the fusible link had been replaced with steel wire to hold the damper blades in the permanent open position. It was a terrible event. So many things in our industry changed as a result of this horrific fire, but this is just an indication of what potentially we're talking about here. These are life safety dampers, and they're designed to keep people from getting injured or killed. So it's really important to specify the right products, to install them properly, and to maintain and test them on a regular basis. So I hope you've learned a little bit from this little overview we've done here in these 5 different YouTube segments on life safety dampers. If you have any questions on any of these kind of products or topics, feel free to contact our office at 860-290-6969. My name's Bill Dunn. It's been great being with you, and have a good day.